Good morning, everybody. Let us start learning. Today we're going to be learning our shir is sponsored Lili Nishmas Leib Asher ben Avram Abish. That is Halevi, that is Mr. Saif's father, whose yahrzeit is Yud Elul this coming Monday evening, Tuesday. Metz Hashem Alimut should be Lili Nishmasai. And he should be a Melitz Yosher for your entire Mishpacha. We also, just to mention that today, this morning, is the dedication of a shul building on Edward Avenue, the Ili Nishmas Mr. Julius Sand, who just passed away this last year. That's going to be for Karen Rosenblum and Tammy Freeman's father is this morning. We also just like to include our learning Ili Nishmas. It's Yehuda Ben Mayor, whose dedication this morning.
Did I join too? My mother-in-law this week.
Okay, and Alan's also adding in for the Ili Nishmas.
Chana River Bas Reb Chaim.
Chana River Bas Reb Chaim, who's
my wife's father.
Okay.
My wife's mother.
Okay. So that's the Ili Nishmas. Alan's mother-in-law, Yud Aleph.
Yeah.
Yud Aleph Elul, this coming Tuesday evening. This topic is one which I've enjoyed immensely learning about, and I've been anticipating talking about and learning with you for a long time. Just never had the opportunity to really get down to it. So it all started a little while back. It started many years ago, actually, with a discussion I had in DC with a friend of mine after a particular drash that I gave. And then recently, actually, Dr. Honigman, who I don't see here today, gave me a book. Dr. Honigman's right over here. So he gave me a book to read called The Quantum Enigma by two physicists from California, Bruce Rosenblum and Fred Kuttner, who wrote on this particular subject, and it is very, very fascinating because it's a very good balance between the science and also it is accessible to a regular reader as well as being a complex book. What I'd like to do with you is the following: let's contemplate this subject from a grossly practical perspective, a historical perspective, and then a Torah perspective. Okay, so three tiers. Here's how it starts, and this is an example the book gives, which I think just helps us sort of gain access to the problem that we have at hand. So here we have it. So imagine you have a scientist. Now this is a scientist who hears about a particular tribe in the Far East that has magical powers. And he doesn't believe in what the stories he's hearing regarding this tribe, so he goes out himself to investigate. They live on the top of a mountain in the Far East. He travels there. He gets a plane to the nearest village. He takes a train to the nearest outpost, and then he goes on a cattle car to the closest place to hike up the mountain to get to this village. And he arrives at the village, and there's a guide there waiting for him, and who understands that he's here to witness the unusual. And so he welcomes this American scientist in, and he takes him to a place where he said we can perform what you call an experiment, which is where we display what the certain observable details. So he said, okay, let's go for it. So he takes him to the edge of the village, and there are two huts that stand 20 feet apart from each other, and in front of the huts is a young man and a woman, all holding hands. And he says, so the villager says to the scientist, what we're going to do is the following. What we're going to do is we're going to blindfold you, and so blindfold him. He says, now what we're going to do is I'd like you to ask the question: which hut are the young man and woman in? So he says, okay. So he takes the blindfold off, and he says, which hut are the man and the woman in? And he says that was a very good question. He opens up the one door on the left, and lo and behold, they're in it. And he opens up the door on the right, and they're not in it. He says, look, perfect. You've seen just demonstratively that your question caused them to be in one hut. So he says, okay, well, that's not very impressive. So he says, well, let's do it again, because, for experimental data, you need to be able to repeat things. So he says, okay, let's do that again. So he blindfolds them again. He says, let's ask the same question. Which hut are they in? Okay, and it turns out they're in the right hut. Okay, fantastic. They do this 7 times, and the scientist is getting a little perturbed. There's nothing really new happening here. So the villager says, well, now we're going to do a different experiment. What I'm going to do is the following. I'm going to blindfold you. And then he says, I want you to ask the question, which hut is the man in and which hut is the woman in? He says, okay. So he blindfolds him and says, which hut is the man in, which hut is the woman in? Turns out the man's in the right and the woman's in the left. And the villager is very excited. The villager says, you see, your question changed where they are. So the scientist says, no. You put them in different huts this time. So he says, well, let's try that again. So he blindfolds him and says, which hut is the man in and which hut is the woman in? And he opens up the blindfold, and lo and behold, the man's on the left and the woman's on the right. So the scientist is not very impressed now. He says, look, I really got to go. It's, I think I've wasted my money getting here. And the villager says, well, how about we do one last stage of the experiment? He says, okay. So he blindfolds him and takes the blindfold off afterwards and says, now you choose which question. He says, okay. He says, well, which hut are they in? So he opens up the door on the right, and they're in the one on the right, and they're not in the one on the left. So he says, you see? Good question. Because you asked that question, they were together. He says, no, that was just very good luck. So he says, well, let's try that again. He says, blindfold you again. He says, now ask the question. He says, well, which hut is here? So I open up the door, and he's in one hut, and she's in the other hut. He says, well, that was also very good luck. And now the scientist starts getting a little puzzled. And so I keep blindfolding him, and each time he opens up the blindfold, he asks a different question, and whichever question he asks distributes them or congregates them in one area, depending on what he asks. And now the scientist is very confused. And the villager says, you see, in the end of the day, your question caused them to be in the places that you asked. And the physicist leaves very, very confused. You see, this example over here, we see the breakdown of logic over here. This example over here is, we'll call it a macro scale of what occurs at the level of a quantum enigma. This doesn't occur with bodies that big, which is part of the question of quantum physics. But we are able to increase the size of this displayable experiment greater and greater today. Let's go back historically, just for a moment. We could start earlier. I'd like to start at the time of Newton, because the history is very, very fascinating as to the development of science, and it should give us a little room for humility as human beings as to how we understand concepts in the world around us. Let's start at the very beginning with Newton. So just to put things in perspective, at the end of the 19th century, 1894, this is Lord Kelvin, one of the extraordinary physicists of the time, a quote from him who said, "There is nothing new to be discovered in physics now. All that remains is more and more precise measurement." And in fact, people were being discouraged from becoming physicists at the turn of the 20th century because we had essentially discovered all that needed to have been discovered. Well, as we stand a century and 20 years later, there is certainly a lot which has been discovered in between. The humility which we need to have. So here's one example of how complex and how much humanity had to learn. And let's start with the problem of light. This is one of the complexities. What is light? Okay, how do you define light? So Newton, who was one of the individuals who really changed the world of physics around him, with his laws of physics, or universal laws of physics, and his questioning mind, where he based the observations he made on experimental data, not just beliefs, which was up till now very much predominant in this Aristotelian medieval way of looking at things, which was adopted up till basically the times of Galileo. Newton transformed the world in the way he produced his universal laws of motion. The one thing which is interesting about Newton is he was a little conflicted, but in the end of the day, he actually had what was called the corpuscular theory of light, which means that he believed that light was small particles which were being emitted from, he called, shiny surfaces, because it followed the same laws as anything which would be a physical entity. It traveled in straight lines, it rebounded off surfaces, it followed all the laws that a regular particles would follow. The reason why he was against the notion, or he was troubled by the notion of light being a wavelength, of being a wave, is because a wave has to travel through a medium, right? So let's say when you're plucking a guitar string and you hear the sound wave, that what happens is that there is a wave which is created between the nodes of the guitar string, which now moves the air, which therefore travels through our ears, and and the air which is moving goes into our ear, which removes the inner ear hairs, and that's how we feel and understand sound. But everything which is a wave actually moves through some medium, and the problem is that light travels through space, and in space there's no medium. There's nothing that can be shaken or waved. So how does light travel through space if it's a wavelength? There must be. It's actually not a wavelength, it's a particle. It's something which is traveling. That's what Newton understood, and in fact, he was debated, he was conflicted about this, but this is what he ended up saying, and for 100 years, in fact, people adopted this way of looking at light, until the arrival of a person by the name of Thomas Young. Thomas Young, I put the biographies of each of these individuals along the way. So he lived in the 1700s, towards the beginning of the 19th century, and he conducted an experiment which turned everything on its head. He conducted an experiment which is called the interference experiment. So what he did was, he took a pane of glass which is covered with soot, and he took his finger and he carved out 2 lines. So now you have a black screen with 2 slits in it. And if you shine light through that screen, now what happens on the other end is very interesting. How does the light express itself as it shines through a double slit screen? So as you can see in the diagram, what ends up happening is that you have bars of light and bars of darkness. Now the problem is that if light were to be a particle, if light is a bunch of particles being emitted, then that result doesn't follow. That result only follows if light actually is a wave. Because what happens is, how does this work? If you have a wave, basically put, if you see in the second diagram on the right, there's the waves being emitted, like if you imagine dropping a stone in water and you see the ripples moving along, those are waves which are being emitted in water. Similarly in air, or in the medium through which light is traveling. So it hits the splits, and now 2 sets of waves are being emitted, right? From each of those holes. And what happens is as the peaks and the troughs of the different waves meet each other, some of them cancel each other out, and there's dark. And some of them, when the troughs hit the troughs, and the peaks hit the peaks, when the peaks hit the peaks, it becomes lighter. So you get bars of light as the patterns of the 2 sets of waves intercept each other. That makes sense, and that's exactly what would happen if light were to be a wave, not a particle. And what happened was after this interference experiment was performed, and we're talking at the beginning of the 19th century over here, what happened was the English school of thought obviously defended Newton's philosophy, because Newton was, of course, in England, and the French school of physics adopted Young's perspective until many more interference experiments were conducted, and it became clearly obvious that light was in fact a wave. And then the predominant view in the world became that light was a wave, unlike the corpuscular view of light of Newton. Fantastic. This just goes to show you the humility. Let's go a little step further. Before we get to Einstein, we meet a man called Max Planck. Max Planck, and notice by the way just the nationalities of all these people. He is of course from Germany, and what he did was he conducted a very interesting. He was dealing with a very interesting problem. The problem was called the ultraviolet problem, and that is the following: is that when you heat up, let's say, a metal, and the higher you heat the metal, the more that the electrons are vibrating in that metal, and therefore the more light they emit. And the higher the temperature, the more they vibrate, and therefore at a certain point they turn different shades of light, till the point that they become what we see as blue, which is supposed to be actually the ultraviolet, which you can't see because our eyes cannot pick that up, because that's the hottest and that's the most vibration that's actually being emitted. The problem is the following: is that according to classical physics, what should happen is that the more you heat it, the more the intensity of the vibration of the electrons should be. So it should go up. It should go up, as you see in the diagram. Classical theory should be that the intensity should increase exponentially. However, the truth is the opposite. Is that at a certain point, at ultra red, what happens is it actually drops off. The intensity, even though you're adding heat, the intensity with which the electrons vibrate actually diminishes. Nobody could explain it. So he dealt with this issue. He tried to understand it. He couldn't work it out. Couldn't work it out at all. So he worked backwards. So he said, let's take a red hot poker and let me watch it now lose its energy and observe what's going on. And he made an argument that in fact that electrons vibrate at a certain point and then mysteriously, for no reason whatsoever, release an amount of energy, which he called a quanta. They release packets of energy. So it vibrates very intensely and then suddenly disappears. It's like steps. They suddenly lose energy immediately, which forms the downward arc of the diagram, which means to say that at a certain point, the electrons are no longer vibrating more vigorously, they're actually losing energy. They're emitting it in the form of light. That's what Max Planck said. He was a very well-respected physicist, and people were so confused by what he said but they couldn't argue with him because he was such a respected physicist, so they basically ignored him. Because it was much easier to ignore him than to have to deal with the very unusual theory that he was professing. Until the days of Albert Einstein. Albert Einstein, of course, as we know, did not start off his days as a glorious physicist. He worked in a patent agency as not even a very high-level patent officer. And in 1905, he wrote 4 papers. The most famous of those papers we know to be, of course, the theory of relativity, right? However, he wrote other papers. And in amongst them, he wrote another paper which deals with light. And he argued, coming full circle round, that in fact maybe light, like Planck had suggested, also works in the same way. Maybe light, in fact, is packets of energy, what he called photons, which means that light is a group of energy which is being emitted, and it's actually an entity rather than a wave itself. It is now emitting energy. What was his proof? His proof was what is called the photoelectric effect. Photoelectric effect was an experiment done where if you shine light on a particular substance, it can be measured that electrons shoot off from that substance. Now that doesn't work if it's just a wavelength. If light is simply a wave, it should bounce off. It shouldn't affect the electrons inside. What Einstein argued is that because light is actually photons, packets of energy, what that means to say is that when it hits there, the energy just charges, transfers to the electrons, which is what causes the electrons to shoot off, some of the electrons to shoot off. This is what Einstein had argued. Einstein, once again, was contravening the natural science of the time, because everybody at this point in time had agreed with Thomas Young's argument that light was in fact a wave and not a particle, and therefore Einstein remained a man apart for the next 17 years. Einstein, I apologize. Yeah, almost 17 to 18 years. This theory of Einstein was ignored in most physics. In fact, in 1922, when he received the Nobel Physics Prize for his work on the photoelectric effect, they didn't even mention the word photon in the Nobel Prize because people were too embarrassed to talk about this photon, which Einstein had been talking about. However, 1923 was a very important year for this because there was a number of discoveries which actually put Einstein back on the map in this respect. So just to reverse to what's going on over here, there's been a movement from corpuscular idea of how light works as particles, which Newton had suggested, back to the interference experiment as a wave, and now the idea that light actually moves in packets of energy, those actually groupings of energy, which is the way that Einstein has described it, based on Planck's experimentation. So here we have 3 very interesting physicists around the early 1920s who develop results which are actually remarkably helpful to us. The first is a person by the name of Niels Bohr, very instrumental, who's a Danish physicist, who is dealing with what's called the stability problem. Okay, so again, folks, the specific details aren't as important, and this is very much a survey as to the bigger picture of what's going on over here, because I was a physics major, but I don't think everybody else necessarily has to be one to appreciate what's going on over here. And that is that he was dealing with what's called the stability problem, which is they were trying to understand how an atom, the structure of an atom. So we have the idea that there's a nucleus. In the nucleus, there's protons and neutrons, and orbiting it are levels of electrons. And part of the stability problem was the following: is if you viewed it as a planetary model, which means that similarly, like the sun is in the center and you have planets orbiting, that's the way that an electron orbits the nucleus of an atom, then you have a little bit of a problem, because a electron is negatively charged, which means to say that it should therefore increase its speed and intensity as it continues to revolve in its orbit, and at a certain point very, very fast, should automatically spiral in and hit the nucleus of that atom, and the atom should be destroyed, which isn't what happens. Now, how does it work? That was what he was dealing with. And he realized something very interesting. He realized that instead of arguing with Planck, remember Planck was the individual who said that, in fact, electrons emit energy in quanta, in these little packets of energy. He instead of arguing to try to find out how does Planck work, how do you derive Planck's constant, which is h, in terms of how much the energy loses, if you accept Planck's theory, you can understand that, in fact, electrons don't just move in a particular continuous fashion. They jump. They jump from place to place, and they emit energy at certain stages, which means to say that there's not going to be a continued intensity, and it's going to implode like you see that the energy of a hot substance doesn't suddenly keep going up exponentially. It loses intensity after a certain point. Similarly with the electrons are not intensely going faster and faster and faster. There's a certain balance of energy which is being created in terms of in an atom. In fact, he was able to use his theory to predict what would happen when you excite atoms, so what light they turn. And he was correct to the 10,000th part. So his theory of using Planck's theory of understanding the internal workings of an atom actually yielded a very interesting result. Why this is important is because it was around this time that we meet a scientist in America, American physicist called Arthur Compton, on the top of the next page, who suggested that in fact there is what's called the Compton effect, which is that if you send a photon of light, if you send some light onto an electron itself, the wavelength of that light changes, which now proves exactly what Einstein had said, which means to say that light as well, if the wavelength of that X-ray photon is going to change, it means to say that it is emitting energy into that electron, like Einstein had suggested, in the opposite direction, which corroborates the theory of Einstein that it's not necessarily only a wavelength if it's losing energy. And it is around this time as well, these are just nodes on the historical calendar, that it became clear that Einstein's idea of light not being a wave, but being packets of energy, being a photon, in fact, became much clearer to the world in 1923. At the same time, that means to say, this is remarkable, that means to say the following. That means that depending on the experiment that was conducted with light, it yielded different results. So let's come back to our hat story for a moment here. If you do an interference experiment, if you do a Thomas Young experiment where you shine light through two slits, you get an interference experiment which indicates that light in fact is a wave, because it gives you bars of light. If you do a photoelectric experiment with light, then it shows you that light is not a wave, it's a particle of sorts. Now how does that work? Meaning, depending on what you chose to do with light, yielded different results. Depending on what question you asked, yielded different results as to where the couple are. Are they separate or are they together? Let's take this a little further as we get into the complexities of this. There was an individual called Louis de Broglie, I'm not exactly sure how to pronounce his name, who took it one step further, who was actually of aristocratic blood, even though he was in the Republic of France. He was an aristocratic line, and he went into physics, and as a graduate student, he made the following observation. If it's true that light can be shown to be either a particle or a wave, what about matter? What about regular atoms and electrons? What about them? We know them to be particles. Could they also be waves? And he set up a theory which indicated that in fact, matter itself, atoms and electrons, not only have the properties of an actual particle, a physical entity, but also the properties of waves, depending on what experiment you use with them as well. Which means that electrons don't just operate as an entity which orbit, they actually move in a wavelength in their orbit. When he actually presented his findings to his graduate advisor, he was told that this was preposterous and it was rejected, but because he came from royal blood, he wasn't happy with his rejection, so he went to find the greatest physicist of the era, Albert Einstein, to present his findings. And in fact, Einstein said of him that he had lifted the veil of God in the world when he understood this, that not only does light have a duality depending on how you experiment with it, actual physical matter itself has two properties depending on how you experiment with it. So now, this is kind of where we left in the early 20s until we come to an individual who is perhaps more well-known. His name is Erwin Schrödinger. So Erwin Schrödinger was, of course, an Austrian physicist. He actually fled the Nazis. He wasn't Jewish. He fled the Nazis and fell in their disfavor. But he observed this for a long time and came up with the following theory. It took him a long time to get to, but he suggested the following. He suggested that maybe every substance which is unobserved, whether it be an atom, an electron, light, actually has what is called a wave function, which means to say it isn't in one particular area. It's over a it can be found at any place within a particular spectrum or area. So therefore, if you take an electron, an atom, which is unobserved, there is what's called its wave function, which means it can be anywhere in that area until observation. Once you observe where it is, the entire wave function collapses because you found out where it is. So now, let's take this a little further. That sounds maybe perhaps obvious. It isn't so obvious. He went to the following lengths, and this is where things get a little murky. So what happens if the following? Well, let's say you produce an atom that has a wave function, so we don't know exactly where the atom is. Okay, so we take even an electron which has a wave function, and we capture it in a particular wave function. So it could be anywhere in a particular area. And now we split that wave function. So let's say we send that wave function through a mirror, and we divide that wave function up into two boxes. Great? So now we have two boxes with this wave function, which means where is the atom? Well, it's anywhere in those two boxes, because it could be anywhere. There's one atom, but its wave function is split over two places. So it could be anywhere, right? It could be in one box, it could be in the other box. It really is at this point in time in both, essentially. We don't know where because it's two areas. Okay, this is what's called the twin box experiment. You can see on the bottom of page 5. Okay, so you have a wave function which is going past a mirror, a one-way mirror. So some of it goes through, some of it is reflected upwards, and you have two boxes, and it's trapped. Let's say trapped between two mirrors in two boxes now is the wave function of this atom. So this particular atom, this physical entity now is essentially in two places at once. Okay, so we don't know where it is. But you're going to say to us, well, it has to only be in one of them, right? Meaning at the end of the day. So here's what we do. What happens if we take a sensitive screen, which we can now track the arrival of atoms in a particular pattern, and we open up both boxes at the same time? What pattern will it yield? So here's the answer would be, is what's called an interference pattern, because in the end of the day, interestingly enough, if you open up both at the time, it's like the two-slit experiment, where light's being shone between two slits. And apparently the two parts of that atom are interacting with each other as waves, and therefore yielding what's called an interference experiment, where you'll see bars of where the atoms hit the screen, only in certain bars and not in other bars, which means that the part of the atom in the one box and the part of the atom in the other box, even though it's one atom, actually know where each other are. Right? They know where each other are, so that when they're released at the same time, they interact with each other. There's something connecting the two of them. However, what happens if you do this? What happens if you open up one of the boxes? Okay, so now you're discovering where the atom was or not. So the atom either leaves or doesn't leave, because it was in that box or wasn't. So let's say the atom does leave. You open up one box, and the atom hits the screen, you hear a plink, it hits the screen, there's a mark on the screen now. And now you open up the other box, of course, is there going to be a plink? No, because the atom wasn't in that box, right? You just discovered that. If you do that, let's say you do that numerous times, and you've got many boxes set up in such a way. If you open them both up together, what patterns are going to yield? Interference. If you open them up one by one, you're going to have sporadic spread of atoms. There's no interference. Which means that the question you asked actually now dictated what's going to happen in the end. Whether it acted like a particle or whether it acted like a wave, depending on how you asked the question. Do you understand what's going on over here? This is over here, going back to the two houses. This is where we start entering into the grounds of what's called a quantum enigma, which means to say that there's a duality in every particle, whether it is every atom, every electron, every photon, whether it is a wave, or whether it is a particle, and depending on how you choose to experiment on it, in the same experiment, you'll yield different results. That's remarkable, and they're not complementary results. Particle and wave cannot coexist, which is what led Schrödinger to say. So some people said, well, that only exists on a micro level. How, so Schrödinger set up a thought experiment, which is of course the famous cat. So he said, let's say you take a wave function of a particular, let's say, electron, and you allow it to open the box, and it could either be a wave or a particle. If it's a particle, it's now going to set off a Geiger counter, which accepts certain, or it can choose to accept different particles which are coming in. If it clicks, it breaks a vial of let's say, acid, which will therefore kill a cat in the box. Which means that it could, until you've opened the box, you don't know if the Geiger counter has clicked. You don't know if the cat has been killed. which means to say up to the point that you open up the box until the cat is actually observed, the cat is alive and dead at the same time. Which means to say what he's done is essentially he's just sort of made it a macro problem. As opposed to saying that the atom is both a wave and a particle, he's saying the cat is both dead and alive physically at the same time, until observed. Which is the Schrodinger's thought experiment to expand the problem that we have at hand. One of my favorite cartoons is the one that deals with Schrodinger's dog, actually, which is the dog suggesting to Erwin to put the cat in the box. But nonetheless, the experiment hasn't been performed because it wouldn't make a difference. In the end of the day, because until observation, the result is the same, so it wouldn't make a difference. Can you get in there to observe while it's happening? You can't, because that observation will therefore interfere with the experiment. Because remember, observation is either you open up one box and you see the result on the screen is the observer, right? Or you see it at the same time, so you're not going to be able to be observing it while it's going on because you're already interfering with the experiment. Which is why doing the experiment won't help, besides the fact that Peter will get involved. So, here we go on the level of physics. Now, interpretation, this is just getting to the historical point to appreciate this. There's a lot more, and what is most fascinating is actually interpretations. We're not going to spend time doing interpretations over here. The Copenhagen, Extreme Copenhagen, EPR, when you get into Bell's theorem, what this means, how does consciousness, how does observation actually relate to the experiment you've done. I like to think about it from the perspective of the Torah. So having put this in motion, and if up to this point in time it sounded a little hazy, let's reverse into Torah concepts, and I think we'll see that in fact, even though it took science a long, long time to reach this idea, that in fact logic, binary logic, doesn't operate, in Torah thought, this is actually a very comfortable concept. Just so we should be aware, this is actually very important, is most of us think, quantum physics, it's pretty much out there, it's not really so relevant. Just so you should realize that about a third of our economy rests on quantum physics. Okay, so computer chips are built based on quantum physics, MRIs, lasers, all based on quantum theory. Okay, so a lot of people spend a lot of time actually utilizing the duality of the elements rather than thinking about them. There's not as much time given to the thought of the enigma behind it, but most of the things we see around us are in fact using quantum theory. So now let's reverse into Torah for a second to appreciate this. Now, let's learn a Mishnah. Once again, we'll start with the Gemara. The Gemara, in fact, is to be found 2,000 years ago. So well before we started experimenting with light. Let's try to appreciate these concepts from their perspective now with the historical perspective. The Gemara tells us the following. In source 1, on page 6. Amar Rabbi Yitzchak, Eina bracha mitzuya ela b'davar hasamu min ha'ayin. Bracha, blessing, Hashem's blessing can only be found in something which is hidden from the eye. Shene'emar Yisava Hashem yitzcha es bracha ba'asamecha. Hashem will place bracha to you on your storehouses. How's the pasuk supporting the idea that the Gemara just suggested? How's this pasuk supporting that notion? Where's bracha found? The storehouses, meaning unobserved. Okay, meaning to say it's not in front of you. Tana devei Rabbi Shmuel, ena bracha mitzuyah b'davar she'ena ayin sholetes boy. Bracha can only be found in a place where the eye does not control it. Shenemar yasava Hashem yitzcha es bracha b'asamecha. Tana Rabbanan, aholech lamud es garnai. A person is going to measure their granary. So remember, you're a farmer. It's come the end of the season now. You want to see what the produce of the year. What was the yield? A person should Hashem, please send bracha in the work of our hands. Hischil lamud, as he starts to measure, he says Baruch Hashalach bracha b'kri hazeh. He gives a blessing to Hashem that Hashem sent bracha to this kri, to this pile. Modad v'achakach birech harezeh tfilas shav. We're going to get into that in a second, the last part of this Gemara, which means to say a very interesting concept. And that is that bracha, the idea of bracha, of course, is the letter Beis. It starts with the letter Beis. Beis, of course, is the basic idea of multiplicity. Right? Where Hashem spreads forth rather than oneness. Beis is where it spreads into two. Where there's the idea of whether there can be more than there is or that meets the eye. The idea, what's the root of the word bracha? There's different ways of looking at this. One is berech, which is the knee. Another one is also breicha, which is a pool. Why? How would bracha be connected to breicha, which is a pool or a spring? What was that? So it's the source, meaning when you go down and you look at the rivers over here, if you track them back to the mountains, there's a breicha. That's the source of where it comes from. When we're asking for the bracha over here, we're saying to Hashem, please allow the flow of your energy to be allowed to be channeled fully into the items that I worked on so that they are now multiplied, now that there's more of them. But the Gemara is telling us that you can only request that before you saw it. Why? Says the Ein Yaakov, Rav Yaakov ibn Chabiv, the idea is that when you look at something, when you observe something, you peg it. It's stuck there. Hashem's not going to now interfere with it because you observed it. You've essentially asked the question. Once you've asked the question, you've defined it. Once you've defined it, you don't leave Hashem the space to affect it. You don't leave Hashem the space to multiply it because He can do that and He will do that. But only when you're on the way to measure it. Once you've measured it, you've got it. You see what's happening over here? Before you looked at it, what was it? Says the Gemara. Well, it wasn't. It had a wave function of sorts. Meaning it could be a lot of things. There's a lot of potential there before observation. When you ask the bracha, Hashem, mashpia your shefa, take your bracha and push it through this channel, there's still space to do that because it is unobserved up to this point. Observe it, you peg it. In fact, this is brought lahalacha, interestingly enough. Another example of just this way that Hashem interacts with the world. Just a classic example in Melachim, where Elisha is dealing with there's a number of stories with Elisha and a woman. So there's one story with a woman who has many creditors, and she's a widow, and she doesn't know what to do. She comes to Elisha. What does he do? He tells her, fill your house with vessels, borrow vessels and vessels and vessels from your neighbors, pots, pans, jugs, pitchers, whatever you can get. And she fills up her house, and she only has one pot of oil. So he says to her, close all the windows and the doors, and pour the oil into those pots. So she pours, and she carries on pouring, and she carries on pouring, and she carries on pouring. Meaning to say that what's happening over here is that she's almost created, it's almost like Elisha has created for her an unobserved area, sort of a space which is beyond observation, which she's allowed privy into. And as long as there's a basis for the bracha, which is the beginning oil that she has, Hashem can expand and that through the bracha as long as she pours, as long as there's space for her. Another example, the Ramban talks about the teva. Now, folks, if you do the physical measurements of the teva, you will come to the conclusive bottom line that there is no possible way that Noah could have fit the entire Bronx Zoo into it. Okay, and the Bronx Zoo does not include everything either. There just simply is no way. So the Ramban says, of course, because there was a miracle that Hashem made it, the physical actually was able to encompass more than it could necessarily, which exists in a number of places on earth. That's very interesting. So how does that work? So the Ramban then asks the question. So therefore, you know what he should do? Hashem should tell him to make a matchbox. Right? If in the end of the day, God operates right beyond the physical, then what's the whole cedar wood? It took him 120 years. Make it easier for him. Tell him to make a little hut, a little shack. He walks into it, just make the entrance big enough for elephants, and then everything walks into there, and it's like Mary Poppins' bag. Boom. Right? So it says the Ramban, no, God has to operate within the confines of observable reality. Hashem allows bracha to be found, but it has to be rationally possible for the bracha to have existed there observably. So God, of course, gives space within the physical to expand and contract, but it needs to be that there's a basis, there's a platform, which is logical. Understand? Observably, it could, potentially. We don't know, we haven't measured. But then on a certain level, there's an expansion and contraction beyond the observability. This is important, by the way, just in terms of it is important to budget, and it's very important to make sure everything adds up, and we know we're going somewhere and we're putting away and so on. There's also a certain time where it's also important to be refreshing one's bank account app every 2 minutes, because you're not really leaving so much space. You know what I'm saying? You're not really leaving the space for Hashem to give that bracha because you're pegging it, like this Gemara is saying over here, based on mission brachas. Let's go one step further. The next dimension where this applies is the mirror opposite of this concept. The mirror opposite of this concept is what's called tfilas shav, where we saw the Gemara actually suggested that if a person has already measured their granary and then says that they ask Hashem for there to be great multiplous brachas, then it's what's called a tfilas shav, which means a in vain prayer. The Gemara gives other examples. There's the Mishnah in Brachas in source 3. A person who cries about the past, hareza tfilas shav. It's a in vain prayer. Examples. Let's say a family is b'shat expecting, and he says concerning his wife, Yiratzon sheteled ishti zachar harezu tfilas. He says, let it be a male child. Well, I'm afraid it's a little too late right now. Okay, it's already been decided. Let's say a person's walking past the city in Rachmaninson, here's a whole a calamity going on inside. Right? And he says, I hope that calling and that chaos is not coming from my house, because it's happened already. It's something which is l'shavar. Now, this is interesting. So, how does this operate over here? So, one second, Mark. So in understanding, the Rambam says is that we can only pray on future things when things can still unfold. There's still space for them to unfold. If you want to take it even one step deeper, I saw in a sefer last night called the Eshel Avram, Rav Avram David of Buchach. He says the most interesting thing on this, as it appears la halacha in Siman Reish Lamed in Shulchan Aruch. He says, think about this for a moment. The Gemara asks on this mission and says, is there no space for rachamim? Meaning, at the end of the day, don't we believe that tefillah changes things? Right? Shouldn't you be able to, like you hear, you see an ambulance going past. He's saying, no, it's done. It's done, the Mishnah said. It's finished. Isn't there space for rachamim? The Gemara says, look at an example in terms of the birth. By Leah, what happens? Leah was pregnant. She prayed that it should be a girl to enable Rachel to have at least 2 children like the maidservants who are boys, who are shvatim. Look what she did. She prayed on something to change the gender of her child, which is exactly the case of the Mishnah, Tfilas Shav. The Gemara gives 2 options. One option is that it was early on in the pregnancy, where this was not yet not yet decided. The Gemara's other answer is, you don't bring answers from Ma'aseh Nisim. That was a nes, which means the teva was one particular way. It was pegged, it was observed. But what did she do? She actually diverted the course of nature through attilas. That's how powerful attilas were, which seems to be a negative thing. We don't like to ask for nisim in general. The Gemara seems to view asking for a nisim as a negative thing to have to ask from God. It takes a lot of schus. There's a lot of problems with asking for a nes. It says the Eshel Avram, Rav Avram David of Buchach. If you think about it from the following perspective, if there is a call of distress and it's coming from a particular area, and you say, I hope it's not from my house, what has happened already is that it has befallen a particular house. For you to change it, not only are you uprooting what has already been observed, the question already asked where that happened, but you're also now transferring it to someone else. You understand? You're now transferring in terms of the amount of neshamas that are coming down to the world. You're now, a fixed quota has happened, and you're asking God to change it. That's very, very hard. It's been observed. Once it's been observed, it's a tfilas shav. Mark, there was a thought?
I think that what you just said now may answer it, but the 2 Gemaras seem to me to contradict each other, because the fact that you're walking into your storehouse, what is there already is there. So if you're about to count it, it says it's not a tefillah shav.
Right, but it sounds like when you're starting.
The reality is there already. Just no different than when you walk into in your town. The reality is there already.
Correct, but it hasn't been numbered yet. Meaning, when I'm starting to now I'm starting to count the amount of bales. I'm starting to measure the amount of grain. Up to the point that I've actually measured it, it hasn't yet been pegged observably.
Right,
That's
so if you're going into your town, you haven't observed your house.
Somebody else has. That's the point.
Yeah, but how about the pregnancy?
What was that?
Pregnancy has not been observed.
What was that?
Once the child is already, the pregnancy exists,
Oh, so that's a very good question.
It's not observed.
That's a very good question about observability.
Of course it has.
That's
before the Uber.
So-
if you would see she's pregnant, then it's already observed.
So first of all, there are all those people in the town who say it's absolutely a boy, right? So besides those people, and before the times of sonograms, I'm not sure. It's a very good question about the pregnancy. I'm not 100% sure on that in particular areas. I think.
Sonograms have an error.
Yeah, you're absolutely right.
So there's an uncertainty principle, uncertainty there which allows you that.
Yes, so even and depending on how late it is again as well, also depends on So that's a very good question, and I'm not sure. Apparently, the Gemara views that as observed already, meaning or fixed enough, which is fascinating. By the crisis in the town, that's clear because there are people there, and you're essentially asking God to uproot what occurred. Right?
If you have a worker, he saw what's in your
But he
storehouse.
didn't measure it, observe.
He didn't measure it yet. You're right. He has limited it certainly, but he hasn't. That's why there's two stages of asking bracha. Right? There's on the way there, and there's measuring it. Right? So one of them could be affected already. Yeah.
There's a whale. If there's a whale,
So, yeah.
there's a whale that
Living
people
things.
know.
Even
Wait,
after he's formed, males can form into females, and females can form in early.
Correct. There is a possibility, which is what the Gemara says. The Gemara says within 40 days. Right, but the Gemara even says originally within 40 days. Let me, if it's all right to be, I want to just move through to two more concepts because we're already running a little late, and then we're gonna take it. We're a little late, so if anybody needs to leave, but I also want to make sure to follow through into two separate realms. And that is what a sheer discussion we followed. We came across many months ago where we talked about Ayin Hara. So how does Ayin Hara work? We discussed many different models of how Ayin Hara works, and one of the ideas which is suggested by Rabbeinu Yonah, already we're about 700 years ago. He says Rabbi Yeshua Mer Ayin Hara, which is talked about in Pirkei Avos. There's many examples of Ayin Hara. You shouldn't stand by people's fields and observe their fields, right? That's the Gemara talks about this. Rav says that when he went to cemetery, 99% of the people died untimely because of Ayin Hara. So how does it really operate? He says, Pirush Misha Eno Samech Bechelka Va'ayin Es Chavera Ha'ashim Mimenu Masa Ye'asher Oisher Gadol Kamoyo V'hu Garem Rala Atzmoy. So a person calls bad to himself every time he thinks about his friend and how well his friend's doing and how perceivably different he is doing. And it affects the other person like the Chachmei Teva says. Meaning, a person looking at somebody else, like the scientists tell us, as Rabbeinu Yonah, can affect another person's property. What? You're just looking at his property in the end of the day. Well, how are you affecting his property? Says the Chazon Ish, in trying to understand this, he says on the top of the next page, it's in Maseches Bava Basra, Yekutzim Chav Aleph, he says, Yavu Bei Rabbanon Einayu V'Nach Nafshe. He quotes a case where the Rabbanon looked at this, in numerous cases in the Gemara, where the Rabbanon look at a particular person, and upon looking at them, the person dies. He says, Misoda Sabriya, it is part of the basic foundations of creation. Ki Adam b'machshavtoi hu menia garmim nistarim ba'olam ha'maaseh u'machshavtoi kala tuchal l'shamesh garim l'hares l'charben shechurban shel geshamim mutzakim. He says it is known that one of the foundations of creation is that one's perception, one's observation can in fact hurt and destroy things around them. Now, the Chazon Ish, what's he talking about over here? He says, and he goes through many numerous examples. What that means to say is that the Chazon Ish understands that observing itself, that looking, consciousness, isn't simply as we think of it up till now, which is there is reality and then there's observable reality. Reality is independent of the observation. That's the general way we look at classical physics. And it's happened or it hasn't happened. The tree fell, whether you heard it or you didn't hear it. However, in the realm of quantum physics, observation consciousness is clearly tied in to what actually happens. Therefore, says the Chazon Ish, Ayin Hara is when you're actually looking and the negative thoughts you're having actually do impact it. Now, on a most basic level, it could be that your impact is you're pegging it. Do you understand? Meaning you're looking at it and you're limiting the bracha that could be now exposed to another person because you've got a very tsar eye on that person. But it could actually be even more than that. He's saying that there is some damage caused by observation, which is perhaps even a further extension. How does this work? Well, how does quantum physics work? How is it possible that consciousness actually interfaces with reality? It does. Another example. This is, by the way, is what the Maharsha says, is why it is that this is why the Maharsha says a person should only say a bracha, bless bracha on his field before he sees it, because when it's seen, it's limited by Ayin Hara, which ties the two in together exactly the same. Let's move into one last dimension, which is completely different. This is a very fascinating dimension, and then the Gemara tells us in numerous places a very interesting concept. Source 7. The Gemara says, Amar Rabbi Abba, Amar Shmuel, Shalosh shanim nechlok beis Shammai beis Hillel. There were for 3 years Beis Shammai and Beis Hillel disagreed. Halalu Amrim halacha kamois, halalu Amrim halacha kamois. In the particular sugya there, one school of thought went like one way, one school of thought went the other way. Yatsa bas kol va'amra, a divine voice was emitted which says, Elu ve'elu, divrei Elokim chayim v'halacha kabeis Hillel. Both of them are the words of the living God, but the halacha is like Beis Hillel. So what does that mean? You're like, How can it be? How can it possibly be both? Another example, Gemara in Chagiga, Daf Gimel Amud Beis talks about Balei Asufos, who are these Balei Asufos, these people who are who live as part of gatherings. Elu Talmidei Chachamim sheyoshim Asufos oiskim b'Torah. These are Talmidei Chachamim who live together and are involved in Torah. Halu Matamim v'Halalu Mitarim. Halalu Oisrim. There's groups, there's always arguments about what is the status or what's in front of them. So you're going to say, look, I don't have time for this. I don't have time to every concept I ask about is a machlokas. How can I possibly get to truth? So the Talmud Lomar, Kulanu Nosnu Miroa Echad. The end of that pasuk of Balei Asufos is that everything was given from one shepherd. Kel Echad Nosnam Parnos Echad Amram. Mibnei Adon Kol Hamasim Baruchu. God gave them. Which means to say that all the arguments they're having are all coming from one God. There's differences of opinion, but they're all coming from one God. Now, how does that work? Because in the end of the day, if there's a machlokes as to is this tamei or is this tahar, it can't be both tamei or tahar. You can't tell me that they're both true, because normatively, on a practical level, I'm going to either be able to eat that or not eat that. I'm either going to be able to keep that in my house or not keep that in my house. There is one truth. Now you're telling me that they all come from God. How does it work with logic? So there's many different approaches given. One approach is given. Rav Moshe Feinstein has his introduction to Igros Moshe. Says, no, you know what it is? Is that sometimes falsehood, or incorrectness actually accentuates the truth more. Which means to say, let's say it's like the null hypothesis. In order to really appreciate the truth, you need to have a null hypothesis which is incorrect to show you that the truth is really the real McCoy. So therefore, what does Elu v'Elu Divrei Elokim Chaim mean? It doesn't mean to say everybody's right. It means to say that the argument necessary to get to the truth, even the false arguments, are necessary to appreciate the true arguments. So Elu v'Elu Divrei Elokim Chaim doesn't mean to say they're true in the ends, they're true in the means, because they're important in the means of getting to the real truth, which is only one directional. That's one direction which is approached. Other people like the Marashal say, you know what it is? It means to say, it doesn't mean to say that there's multiple truths. It means to say that really there is one truth, but everybody's trying to get to the truth. Therefore, Elu Divrei Elokim Chaim means to say we're crediting them on the process, the effort of trying to get there. It's not, of course, there's only one truth. It is Tahor, it is Tameh. There simply is no other way around it, says the Marashal. But nonetheless, we credit the process of trying to get to truth as Elu Divrei Elokim Chaim. Those are more classical explanations. However, now we come to the quantum physics model. And this is an approach, the Rav Dessler talks about this, the Alei Shur talks about this, the Maharil, if we read carefully, actually talks about this in the following. So, the example is given in the following. The Gemara talks about in Gittin a particular case. There's a fight between, I didn't actually put this in the sources over here, but in Gittin Vav and Beis, there's a discussion about the Pilegesh Begiva. Pilegesh Begiva, a terrible incident where a man separated from his wife, brought her back, and there was this whole terrible rape, murder, and civil war. Very, very dark era in Jewish history. Why did he separate from his wife in the first place? The Gemara wants to know. So the Gemara says two options. One is that because it was something to do with the intimate relationship, Nima Matzala. The other option was that Zuv Matzala, that in the cooking there was a fly, meaning to say that we'll call it the gastronomical quadrant of their lives. He felt that it was unacceptable. Okay, so the Gemara says they went to Eliyahu and they said, what was the truth? Meaning, if you're to reverse back historically, what actually happened if you had a closed circuit camera in their house? What happened? So what does Hashem say happened? So Eliyahu says, Ikad Amri, Nima Matzala, Ikad Amri, Zuv Matzala. Meaning God says both. Wait a second. It either was one or the other, so the Gemara says no. Really what happened was both occurred. The question is what started the problem, and what was the straw which broke the camel's back? Which means that both could potentially exist, even though to us the two couldn't exist, but naturally there was a problem in the relationship in two areas, and both were in fact true. Which means to say the Gemara is suggesting that the notion of Elu v'Elu Divrei Elokim Chaim doesn't mean to say that just for the effort, or just because of accentuation of the correctness, that they're both true. Maybe what makes them both true is that we can't necessarily understand how the two can coexist, but there is space in what occurred for both to actually coexist. Just a very basic example, they say they take 4 blind men into a room, and they ask them, what do you have in front of them? So it's an elephant. So what happens is each of them goes in, makes their observations, and comes out, and and they ask the report, what did you find there? So one man says, an elephant is like a tree trunk. The other one says, an elephant is like a hose pipe. The other one says, an elephant is like a rope, and the other one says, an elephant is like a brick wall. And what are they talking about? They were in the same room. It was the same elephant. What was happening? So it depends what part of the elephant they were touching. If the one was hugging the leg, that's a tree trunk. The one was holding the trunk, that's the hose pipe. The one was holding the tail, that's the rope. The one was patting the stomach, that's like a brick wall. So meaning to say, are they incorrect? They're not incorrect. They're describing the same reality, but they don't have access to the full reality because that's the only part of the part they have access to. What is evoked over here is that perhaps on an even deeper level, what it means to say is that there's certain concepts. Let's say you have a particular item in the world. Is it asr or mutter? So the way Rav Kook understands this is that item has 73% heter, but it also has 27% of isur in it. So when there's an argument about it, what's essential? What's elu ve'elu devar elokim chaim? Is they're accentuating the dual definition of that item, of that entity in the world. How does it coexist? Well, the answer is God created it in a way that it has both elements within it. And their argument is because they're accentuating both elements, which is why Rav Kook says famously in his Siddur that that wise sages bring about more peace. Now, that's not really exactly accurate. They're arguing all the time. That's not so peaceful. So Rav Kook says no. Shalom isn't peace. Shalom is shleimus, is completeness, wholesomeness. How do you arrive at wholesomeness? When you get closer to the holistic truth. The fact that you can have a concept which is both. And Elu means to say, actually, they are both objectively true. Normatively, we have to paskin one way. We're going to paskin the roiv. It is 73% mutter in the end of the day. But in definition, they're both correct. They're both absolutely right because that aspect, that atom, had both views within it. Let's take a look at the last quote over here. Just this beautiful quote of that is to be found in source 16. This is Rav Ronnie Ziegler who's talking about the lonely man of faith, and he says the following: Rav Soloveitchik's book, The Halachic Mind, establishes the philosophical basis for the assertion of the cognitive and methodological autonomy of halacha. Actually, like the lonely man of faith, the halachic mind focuses not just on halacha, but more broadly on the religious realm in general. In this very technical work, the Rav claims that the epistemological pluralism of the 20th century science allows us, for the first time, to develop a genuine and autonomous philosophy of religion. Epistemology is a science of knowledge, dealing in the question of how we know things. Just as contemporary science, especially quantum physics, as opposed to Aristotelian and Newtonian physics, admits a variety of ways of viewing the world and a variety of sources of knowledge, so too must philosophy. Therefore, the elements of a religion, in our terms, the details of halacha, can serve either as the basis for formulating a worldview which is no less valid than any other. Since science and philosophy no longer claim to describe everything knowable, there is now room to turn religion as a source of knowledge, and religion is now free to explain itself in its own terms. Which means to say that it took a long time for humans to catch up on the scientific front to allow us to understand the tools to be able to re-understand the Torah in a better way. But the Maharal was talking about this for centuries in understanding the complexities of conceptualization. It just took us a little while to get there, to be able to understand, to be able to have models for it, to be able to go back into the Torah world to fully understand the complexities beyond the binary logic with which we operate. Anyways, I hope this was meaningful and room for further discussion. Thank you very much, ladies and gentlemen. Rabbi Chanan ben Akash Amar Atzah Kadosh Baruch Hu L'Zakos Yisrael Lefichach Yer B'Olam Torah Mitzvah Shneimar Adonai Chavetz Saman Tziko Yagdil Torah V'Yadir.